Hello, everyone. So in this video, I'm going to talk about how to prove the Pythagorean theorem by similar triangles. Okay, so if you're watching this video, you should have some sort of background about the similar triangles. So that is what we are going to use. Okay, so but make sure you get every single step as we are going to prove this relation. If you don't get some of the steps, please don't resume. Okay, just make sure you stop and digest and convince yourself that you really get what's being um, talk in this part of the video. So before you move on, okay? Anyway, so let's say what we are given. So we have the triangle DMON, and now we are given A, B, X, and Y, as well as the C as a hypotenuse of the large triangle. And we are given the altitude of the triangle to the hypotenuse. And we want to see that A to the second power square of the length and the square of the other leg equals the square of the hypotenuse. And this is called Pythagorean theorem. So to prove this relation, we are going to use a couple things at once. The first part, okay, we are going to prove a square, which is the one part of the relation, is equal to c times x. C is hypotenuse of the larger triangle, and x is the side, one of the lengths of this triangle. And then A is hypotenuse of this smaller triangle, as well as the leg of this larger triangle. So it looks like we are going to need to use this triangle. So, and then this larger triangle. So, which is why I'm going to actually go ahead and split those so we can actually see how they are related. Okay. So let me do this. And we will have the other triangle as well. So I hope that will help you to make sure you really get what's gonna happen, okay? So this is a right angle O, and then I have M, and then we are given this guy right here, and then that's N. So, and this is, this is 90 degrees, so which means this guy will be 90 as well, which wasn't given, but we can easily say this is a straight line. So if this is a height will make, altitude will make 90 on both sides. So that's gonna be the case. So that's M, that's P, and that's O. And we are told this is A, this is X, so this is A, and this is C, okay? So based on this, we wanna see if these are actually the similar, and we wanna get some relation from there. But without really seeing the choices, we can actually make some sort of reasoning, to be honest, but I'm gonna use the choices. So it says the first step, maybe I should label those with the same color. So you know the angle M, which was right here, so maybe I should color right here so we can see how they are actually related. So this angle in this triangle and this triangle is actually the same angle. We call this reflexive property. So, but we'll see that. So the angle NOM, okay, angle N, okay, this is N, OM, which is this guy, is 90 degrees. Okay, and then we are told this is congruent to OPM. So OPM, so this was 90, so this is also 90 because we dropped the altitude. So this is 90, and so this is 90 as well as this is 90. So all right angles are congruent. So we have two 90 degrees. This is a 90 degrees in the larger triangle, and this is 90 in the smaller triangle. So both right angles are congruent. So that is our first statement, okay? And the reason is they are all congruent if they are right angles, okay? And the second reason is the OMN, which is, actually, let's do it this way. The second reason is OMN, which is this angle that I colored purple, is congruent to PMO, which is actually the same angle. Okay, so basically we are told the angle OMN, which is this corner angle, is congruent to PMO, which is the same angle, but we are kind of showing a little bit differently because in this case, we are talking about the angle in the larger triangle because we are using OMN, which is OMN are the corners of the larger triangle, which is this one. But in this case, we are saying PMO, which is this same angle. So they are congruent to each other because they are the same angle, and then we call this reflexive property. So let's see if we have something like this one. So we are gonna have the reason as reflexive property. So let me see that. Yeah, this one. So the second reason is corresponding angles in a similar triangle are congruent. We didn't really prove they are similar yet, so we are trying to prove that. So now we have this angle is same as this angle. This 90 is the same as this angle. So which means we are already done with the proving the similarity, because if you remember, we have three ways to state that triangles are similar. One of them is the angle, and the other one side, angle, side, and the last one is side, side, side. So these are the three ways that we can prove the triangle similarity. In our case, we are using angle because we have two angles are congruent already. So then we are done basically proving the triangles are congruent. So the triangle M and O, so this is M, this is O, and this is N. So M and O, which is M and O, this triangle is congruent to MOP. So MOP. So the order doesn't matter. You know, it's, you start with M, which is the angle in purple. We should go with the M in purple, which is going to be the first letter in that similarity statement. And the second letter is N, which is the angle that we didn't name it, which has to correspond to this O, which is actually middle one in the second statement, which is correct. And then O in my larger triangle is right angle, should correspond to P, which is 90, as well as we saw that's the case. So now we can see these are similar. The reason they are similar, we have two angles are equal. So that's basically angle similarity. Okay, so if you can prove two figures are similar, which is what we just did, we can conclude two results. The first, they will have all angles are congruent. In this case, we prove two angles are congruent, so which will make the third angle are also equal. And the second result, all sides are going to be proportional. So, and then we can write that in our statements. Let's see what we have next. So A over X, okay. A is our this guy, X is this guy, but maybe we can see this is A because we were starting with the larger triangle. A is the side in this larger triangle is opposite to this angle N. Angle N was opposite to, is congruent, like corresponds to this O. O is opposite to X. So which is why A over X is my first fraction, first proportion, is equal to, so what I'm saying basically, we are going to start with this angle, which is opposite to A, the same angle on the other triangle opposite to X, right? That's my first relation. But in this large triangle, I don't know ON, so, but I do know this hypotenuse, which is C. So I should go with C over the hypotenuse in the other triangle, which is opposite to 90, is A. So I should have this relation because that is the other information that I do know. So let's say C over A. So that's the case. And then we got that as our next step. So A over X is given. So let me write here, A over X is equal to C over A. But the question was asking to prove A squared. So if you do cross multiplication, so A squared is equal to C times X, which is what we were trying to prove. And then when we multiply both sides by AX, or if you do cross multiplication, so that's kind of give you the same thing. So you actually got the A squared equal to CX, okay? And we are done with the first part of the proof, which is the question was asking. So then we are done with this. So basically while we are doing this one, we prove that the square of A is equal to this piece X times the hypotenuse. And if you use the similar way, you can prove actually B squared equals C times Y, which is the square of the other line is equal to this piece Pn times the hypotenuse, okay? So that is exactly the same thing as the first part. Only difference is now you are going to use this triangle and the larger triangle to do the similar step. And you got the second relation, which is I'm going to just show you because that's already given. And you're going to see the angles are congruent and reflexive property, angle similarity as we did at the end. So you're going to get the exact same result. So now we have two results. A squared is equal to x times xy. B squared is equal to y times c. But we want to get this guy, right? So this was the question. So we just prove a squared equals x times c, and b squared equals y times c. But if you want to find a squared plus b squared, so it's just, we are going to add these guys. So that will be a squared plus b squared equals cx plus cy. And then, you know, c's are common, so I can pull these c's. So that should be x plus y equals a squared plus b squared. And since x plus y in this hypothesis is actually same as c, so then we can replace those, which is going to be c times c, and that will be c squared. And that is actually going to be our proofs. So a squared plus b squared is going to be c squared. But let me show you that just to make sure how we want to make it a bit better way of saying it. So we just write a squared plus b squared equals cx plus b squared. So what we did basically to get this guy, you know, a squared plus b squared, you know, a squared was like, you can add the first statement, you know, we got the a squared equals cx. If you want to add b squared to both sides, so you got a squared plus b squared equals cx plus b squared. We just added. You could do this one, but they didn't do that way. And then we got a squared plus b squared equals cx and cy. So this is exactly the same as what we got as the part b, which was b squared equals cy. We replaced that, we substitute basically. And then we pull this c as a factor. So we factor this expression to get c times x plus y. And then x plus y is the same as c, because that was in the figure. So x is the part of c and y is also other part. So the sum of those two is actually c, so segment addition. And then if you replace that x plus y with c, that will be c times c. You just substitute, and then you got this as your last step. So it's basically not one of the proofs of the Pythagorean. So I hope that makes sense, okay? So I'll see you in the next video.